Section 1.7 has one big concept that breaks down to two pieces. Basically, it's that if you have a line and you want to figure out another line that's going to be parallel to it or perpendicular to it going through some specified point, the thing that you have to focus on is slope. So two parallel lines are going to have the same slope, although they'd have to have different y-intercepts because lines with the same slope and the same y-intercept would be the same line. But the important thing is two parallel lines have the same slope. And then for perpendicular lines, the slopes are going to be negative reciprocals of each other. And the thing to watch out for, I think, is the negative. So it's easy to remember that they're reciprocals, harder to remember negative reciprocals. The other way of saying it is that if you took the original line and then your new perpendicular line, and you took their slopes and multiplied those together, that you'd have to get -1. So the way it works would be like this. Like if your original line has a slope of 3/4, then the negative reciprocal of that is going to be -4/3, right? Because the regular reciprocal is 4/3. So you would end up with that. So lines with those slopes are going to be perpendicular to each other. And let's see, with these down here, this first example, basically we're just getting negative reciprocals. So one other thing I should point out is there is shorthand for perpendicular, which is like this. So to make that symbol instead of writing out the word perpendicular, because two perpendicular lines are going to intersect at a right angle. So to write perpendicular with that sort of upside down T, that's what that's supposed to represent. It's supposed to look like two lines intersecting at a right angle. But for a perpendicular line, you'd want the negative reciprocal of 2. So the reciprocal of 2 is 1/2, but we're going to want -1/2. And I think we can see it in the picture, even though this graph came out weird. The x-axis didn't come out. I don't know why that happened. But let's say we're just going to take some points. So for the original line, let's just say it goes through the origin. So a slope of 2, if I go over 1 up 2, I guess then I'm about here. And then if I go 1 to the left and down 2, I'm down here. So then the original line is going to go like this. Right, so this is a slope of 2. So there's m equals 2. And then if I start at the origin again, and for a -1/2, let's see, if I put the negative with the 1, then let's see, it's 1 down and 2 to the right. So that's over here. And then the other way that I could get one is if I start at the origin and went 1 up and 2 to the left, which is there. And then if I connect those together and draw on that line, I'm missing a little bit, but we're going to get the right effect. So my drawing's not perfect, but I think you can see the idea. So the slope there is -1/2. And these two lines are going to intersect at a right angle. And by definition, that's what two perpendicular lines are supposed to do. So that's the idea, and that's why it needs to be a negative reciprocal, so you get that effect. Right? If the sign didn't switch, so if it was a reciprocal instead of a negative reciprocal, there's no way to get that right angle. All right, then going to the next one, if the slope of the original line was -2/5, then for a perpendicular line, we should have a slope of, well, I guess if you're going to do it literally, you'd have the negation of -5/2, since the reciprocal of -2/5 is -5/2, but then we have to negate it. But we're negating a negative, so I think the more conventional way to write that number is just 5/2. Then we have C, which is kind of the weird one. What if the slope is 0? Well, if you try to take the negative reciprocal, like if you say, even if you're just going to try to take a reciprocal of 0, you say, okay, well that's equal to 0 over 1, so you take the reciprocal, you get 1 over 0, negative reciprocal is -1 over 0, that's undefined. Yeah, and you can see why if you use the picture over here. I'm just going to draw on a line with a slope of 0, because that's going to be one that's horizontal. So, like there's a line with a slope of 0. And then what would be perpendicular to it? Well, what would be perpendicular to a horizontal line would be a vertical line. So if I just draw on one of those, right? Then we're going to get the right angle. But a vertical line has an undefined slope. So for a perpendicular line, I'll just say M is undefined. And this would work in the opposite direction too. Like if you started off with a vertical line with an undefined slope, then what's going to be perpendicular to that would be a horizontal line with a slope of 0. All right, next, if we're given a couple of lines to figure out if they're parallel, perpendicular, or neither. Okay, so what we're looking for, parallel is that have the same slope. Perpendicular is negative reciprocals, and if neither of those two things happen, then they're not parallel and they're not perpendicular. So then looking at these, because here we don't actually have to solve anything, and you can tell in the rest of them, it's probably better to get the equations of the lines into slope-intercept form, because that way you can look right at the slope. But A, they're both in slope-intercept form already. So the one on the left, you go, well, the slope there is 3. And the one on the right, the slope is negative 3. Those aren't the same, and they're not negative reciprocals. Right? One is the negative of the other one, but it's not a negative reciprocal. The negative reciprocal of 3 is negative 1/3. So this one is actually going to be neither. Okay, so we got a neither out of the way right off the bat. B, we got to do a little bit of work first. I think it would make sense to get both of those written in slope-intercept form. So I'm going to go ahead and do that. I guess on the left I'll get the negative 4y by itself. So negative 4y equals negative x plus 8. And then I want to have this solve for y, so I'm going to multiply both sides by negative 1/4. So negative 1/4 times negative 4y equals negative 1/4 times negative x plus 8. So then we're going to have that y is equal to, so negative 1/4 times a negative 1 would be 1/4. So 1/4 x and then minus 2, right? Negative 1/4 times 8 will give you that minus 2. All right, and then this one over here. So 4x plus y equals negative 1. It's easier to get the y by itself this time. So just subtract 4x on both sides, and we're going to get that y is equal to negative 4x minus 1 if you write that in slope-intercept form. And if you look at the slopes, we got a negative 4 here, and that first one we had a positive 1/4. Those are negative reciprocals of each other, right? Since 4 and 1/4 are reciprocals, but then these two have opposite signs, that's what you want to see for two lines that are perpendicular, right? So the slopes have negative reciprocals, and that means that the two lines are perpendicular. All right. Next one with C, one of those is in slope-intercept form, the other one's not, so I guess we should take care of that one on the left. So subtract 3x from both sides, and we're going to have 5y equals negative 3x plus 9. And then either divide both sides by 5 or multiply both sides by 1/5. I'm going to multiply by 1/5 because I think it'll make the right side a little bit easier. And then, we're going to get just y by itself on the left. And then if you distribute the 1/5 on the right, you're going to get negative 3/5 x plus 9/5. All right, so the slope is negative 3/5. Slope in the equation on the right is also negative 3/5. So same slope, and that means that the two lines are parallel. All right, and then D, well, you might be able to see this one right away, and even if you don't, there isn't a ton of work here. This one is already in slope-intercept form. It's just usually written with the y on the left, and if you want it that way, you can do it. Here, I guess I'll just multiply both sides by negative 1. That way we'll end up with a positive y instead of a negative y. So then we're going to get that negative x is equal to y, or y equals negative x if you want to have it written with the y on the left. So if you look at these two, one has a slope of 1, the other one has a slope of negative 1. those are negative reciprocals because the reciprocal of 1 is 1, right? 1 over 1, you just interchange the denominator and numerator, it's still 1 over 1. So the slopes are negative reciprocals, so these are actually going to be perpendicular. All right. Okay, so I think that takes care of number 2. Numbers 3, 4, and 5, although really mostly 3 and 4, are going to be the most common types of questions that have to do with this sort of thing, where it's going to be something like, here's the equation of a line given in standard form, so you got to do a little bit of work to figure its slope out. And then we want a parallel line or a perpendicular line that goes through some specified point. And 3 and 4 are exactly that, right? 3 is a parallel line, 4 is a perpendicular line. But other than that, that's basically what we're going to do. So the first thing that we have to do is we have to figure out what the slope of this line is. Because if we're going to get one that's parallel, then it needs to have the same slope. All right, so 6x minus 8y equals 9. I want to figure out the slope of this. So I'm just going to get the y term by itself and then get y by itself. So if I subtract 6x from both sides, then we're going to have that negative 8y equals negative 6x plus 9. And then I'm going to multiply both sides by negative 1/8. So negative 1/8 times negative 6x plus 9. And so then this will just be a y on the left side. Negative 1/8 times negative 6. It's going to be positive 6/8, but most people would call that 3/4, I think. So I'm just going to go ahead and reduce it now. So 3/4 x and then minus 9/8. Right? 9 times the negative 1/8. The key thing is the slope, right? So the slope is 3/4. That's what we're looking for. So then over here, to get the parallel line, so what we know is that we're going to need the same slope, so slope of 3/4, and then the point is going to be negative 6, 1. And what we're going to do is we're going to use the point slope form. Since we have a point and the slope, it seems like it makes sense that you would want this, right? The point slope form where you have y minus y1 equals m times x minus x1, where x1 and y1 are the coordinates of your point. Then we can just sub in and say this will be y minus 1 equals 3/4 times x minus negative 6. So really that's an x plus 6 in there, right? So y minus 1 equals 3/4 times x plus 6. And then distribute the 3/4. So we're going to have 3/4 x, and then I guess plus 18/4. So let's see, it looks like that's where we're going to end up. So 3/4 x plus 18/4. 18/4 could be reduced, right? It's the same thing as 9/2. I'm going to reduce it in the next step because I'm running out of space rather than having a reduction just kind of by itself. So let's see here. We're going to end up with y equals 3/4 x. That's not the greatest looking 4. Let me fix that. So 3/4 x. And then plus 9/2 plus 1. But the 1 you could write as 2/2. Right, so we're gonna get y equals 3/4 x plus 9/2 plus 2/2 to get a common denominator, and then what's going to be the final answer would be y equals 3/4 x plus 11/2. All right, so it looks like that's what we've got there. So not too bad, right? You take the general form, or standard form equation, rewrite it so it's in slope-intercept form so it's easy to see the slope. And then we said, oh, it's 3/4. And this is a parallel line, so it's got to have the same slope. And from there, we can use the point-slope formula that we had in the last section. And with number 4, that's basically the same exact thing that you do, except that the line that you want, number 4, is perpendicular, so you have to use the negative reciprocal of the slope instead of the exact same slope. That's really going to be about the only difference. So we still have to kind of do the same thing at the beginning. We're going to want to know what the slope of this line is, and it would be easier if it was written in slope-intercept form. So 8x plus 3y equals -5. And then we're just going to get the 3y by itself. So 3y equals -8x minus 5. And then multiply both sides by 1/3 to get y by itself. All right, so we're going to get that y is equal to -8/3 x minus 5/3. So then the slope is -8/3. So then for a perpendicular line, then the slope should be equal to 3/8, right? Negative reciprocal of -8/3. So to get our perpendicular line, which I guess I can do it over here, I'll kind of set this one up the same way I set the last one up. We know the slope is going to be 3/8, and then our point is going to be 8, -9. All right, so then we can use the point slope form again. And so y minus y1 equals m times x minus x1. And if we sub in, we're going to have y minus -9 equals 3/8 times x minus 8. And so it's going to be a y plus 9 on the left. And then on the right, that's going to be 3/8 x minus 8 times 3/8, but that's minus 3, since those 8s are going to cancel out. And then to get this into slope-intercept form, I'm just going to subtract 9 from both sides and say then that y is equal to 3/8 x minus 12. And that is the answer right there. All right, so about the same with number 4 as with number 3, except that it was perpendicular this time, right? So negative reciprocal for the slope of the new line. That's about the only difference there. All right, 5 is actually nice and short. It's still parallel and perpendicular lines, but it's about ones that are horizontal and vertical. These tend to be really fast. So we want to find the equation of a line parallel to y equals 1, passing through -2, 3, and then perpendicular to y equals 1, passing through the same point. Okay, well, first of all, where's y equals 1? It's right here. So I'm just going to make a dotted line for y equals 1, just so we know what we're dealing with. So there's y equals 1. It's a horizontal line. So for the so I guess I can put that in here. So y equals 1 is horizontal. So a parallel line that we want in part A, that should also be horizontal. So we want a parallel line through -2, 3. All right, well, -2, 3, that is, there's 1, 2, 3, right there. So a parallel line should just be another horizontal line. It's got to go through that point. So it looks like y equals 3 would go through that point, since that's the y coordinate of the point, and that's about all you need here. So y equals 3, which I guess I could draw in. I'll draw this one in not dotted. So there's y equals 3. And then if you want a perpendicular line is going to be vertical. So we want a perpendicular line through negative 2, 3. And a vertical line that goes through that point looks like it's x equals negative 2. So then it's just going to be something like this. There. So when you have horizontal and vertical lines and you're trying to figure out something that's perpendicular or something that's parallel, you don't have to do all that work that we did in 3 and 4. It's much, much faster. So I did want to work one of those in just to kind of show that, but also because this does show up, right? Like this does happen every once in a while. And it's worth going through because the procedure is not the same. I mean, if you tried to do that, you would run into trouble because, like, if you tried to get a perpendicular line here and use the point slope formula, then you get an undefined slope, and then how are you supposed to use the point slope formula? So basically, you just have to kind of reason your way through it and go, well, the thing that intersects a horizontal line at a right angle would be a vertical line, and you just kind of have to do it like that. All right, number 6. This is a little different. This is about as hard as this section would possibly get, but I thought it was worth getting one of these in here. So what we're going to have to do is we're going to have to figure out what b is. So it's some number, but we need the line on the left and the line on the right to be perpendicular to each other. So what I would do is get both of them in slope-intercept form, and then we can use that if they're perpendicular, the slopes have to be negative reciprocals, and that should give us enough information to solve for b. So, all right. First one, the one on the left, we got 2x plus by equals negative 6. So I'm going to get by by itself and subtract 2x from both sides. And then we're going to have that by is negative 2x minus 6. And then solving for y, I guess we're going to multiply both sides by 1 over b. So 1 over b times by is equal to 1 over b times negative 2x minus 6. And so then y is equal to negative 2 over b minus 6 over b. All right, so for now we're just going to have to leave that like it is. And then over here, get this one to slope-intercept form as well. So we got 12x plus 3y equals 11. So I'm going to subtract 12x from both sides. And then we're going to have that for some reason I thought that was a 13. It's not, it's a 3. All right, so 3y equals negative 12x plus 11. And then we're going to multiply both sides by 1/3, or if you like, divide both sides by 3. I'm doing it by multiplying both sides by 1/3. And then we're going to get y by itself on the left. On the right, 1/3 times negative 12 is negative 4. So we're going to have negative 4x and then plus 11/3. All right, so then since the lines are perpendicular, we need the slope over here to be the negative reciprocal of negative 4. So the negative reciprocal of negative 4 is going to be positive 1/4, right? Reciprocal of 4 is 1/4, right? And then we got to make sure we're switching signs here. So I guess then we'll just say that to be, that's supposed to be an E, not an O. But to be perpendicular, then negative 2, that's missing an X there. Negative 2 over B must be equal to 1/4. All right, so then if negative 2 over b equals 1/4, then you could take the reciprocal of the top and the bottom, and I'm actually going to put the negative with the 2. You could put it with the b if you wanted to, as long as you put it somewhere. So I'm going to write the reciprocal of the left as b over negative 2, that's equal to 4 over 1. And then to solve for b, you would just have to multiply both sides by negative 2. So then b equals negative 2 times 4, which is negative 8. And that should do it. And if you think, yeah, negative 2 divided by negative 8, that's 2/8, which is 1/4. So yeah, it looks like that works. But that, I think, is about as tough as it would possibly get with this sort of thing of figuring out parallel and perpendicular lines. So number 6 is a little bit different. The most common things, like I said, would be questions like 3 and 4 in here, where it's just, here's the equation in standard form, here's a point, get the parallel or perpendicular line to this given one that goes through this point. That's usually what you get. And then once in a while you get something like number 5, where it's that sort of thing, but there's a horizontal or vertical line, and when those show up, the amount of work that you have to do gets cut down drastically, which is nice when that happens.